morning. My name is Lloyd Danzig. I'm the chairman and founder of ICED AI. We're a 501c3 nonprofit dedicated to ethical issues in the artificial intelligence space. And I'm also the founder and CEO of Sharp Alpha Advisors. We're a sports, gaming, business, and investment consultancy with a focus on companies deploying cutting-edge tech. And at the intersection of those two disciplines lies that which I'm here to present to you, a modern love story, machine learning engines, and the global sports betting industry. So I want to start just by way of agenda by giving a quick overview into what the state of this industry is, particularly here in the US right now, discuss the two main competing revenue models that you see most commonly, discuss how predictive analytics have played a role in this space historically, talk about some of the next-gen statistics that are being collected and fed into some of the modern models, and then get to the bulk of the presentation, a deep dive into the various machine learning use cases. Then, of course, happy to take any questions. If not, I have office hours from 1:15 to 2 o'clock right after lunch. So for anyone who's not aware, last May, a 1992 piece of legislation known as PASPA, the Professional and Amateur Sports Protection Act, was repealed, thereby granting each state the authority to decide if, how, and when to regulate sports betting within the confines of their borders. I have behind me the most recent iteration of the legalization map put out by the American Gaming Association. It's current as of a couple of days ago. And I think there are two macro takeaways here. One is that an extraordinary amount of work has been done by policymakers in a relatively short period of time, especially given how long policies often take to be made. About 18 months is what was taken to produce the map behind us. But there still exists an incredibly fractured legislative landscape that more likely than not is serving as an impediment both to investment and innovation. Nonetheless, the economic impact has been fantastic. It's estimated that a fully mature sports betting market in the US would add $41 billion in total output across not only taxes and labor income, but ancillary services, technology, and the like. Not to mention between 125 and approximately 150,000 jobs expected to be created, all here in the US. Some future trends to be aware of. Wouldn't be relevant if I didn't talk about eSports and betting on eSports. Customers and fans are expected to wager over $30 billion on eSports competitions next year alone, generating over $2 billion in revenue from the people who operate those sports books. New Jersey, during the current League of Legends championship, is the first state in the US to officially sanction legal and regulated eSports betting. There are some challenges. One is a lack of reliable data, and two is the prospect of match fixing, but nonetheless, anyone who is even vaguely familiar with the space knows there has clearly been a paradigm shift in what is considered a sport and what people like to be fans of and wager on the outcomes of. Sports betting bots function just as they do on Wall Street and financial services. You have sophisticated forecasting models that particularly like to pursue arbitrage opportunities algorithmically and instantaneously when they arise. As with many industries, the blockchain use cases are pretty compelling. For online casinos in general, you have digital blackjack tables and roulette wheels that are stamping the result of every hand and spin on a distributed immutable ledger so that in the long term you can reconcile the distribution of outcomes with the odds and the payouts that were advertised at first. And this has given rise to this term provably fair gaming, something that many people who may have played online blackjack in the past perhaps doubted was actually in place. In terms of sports betting, the ability to use fully funded, essentially digitally escrowed smart contracts offers this notion of guaranteed and instantaneous payouts, something that, again, especially with people who have a history of betting with offshore bookies and unsanctioned companies, have not exactly had the luxury of enjoying. There are two competing revenue models in this space. The first is what you'll see if you go to Las Vegas, Atlantic City, you log on to DraftKings or FanDuel, and that is called a fixed odds sportsbook. And that is one in which a customer views odds that are set by the operator and chooses whether or not to engage with them. So to use a hypothetical example, I have this little table on the top right of a matchup between the Knicks and the Pistons. And the way you would read this is, if you look in the second column of numbers, the plus 5.5 means the Knicks are 5.5-point underdogs. If you want to bet on them, you look at the final score, you add 5.5 to the Knicks, see who won, and whoever wagered on that team wins that particular bet. But for this hypothetical example, I'm going to talk about the first column of numbers, which is what is known as the money line. These are the odds on which you bet on a team to win regardless of the margin of victory. The plus, again, indicating an underdog, so a $100 wager on the Knicks, if successful, would lead to a $190 profit. That is the definition of plus 190. Whereas the minus indicates a favorite, meaning if you wanted to bet on the Pistons, you would risk $225 to win 100, the definition of minus 225. So suppose we had two hypothetical customers, Alice and Bob. Alice wants to risk $100 on the proposition that New York will win, while Bob wants to risk $225 on the proposition that New York will lose. It's a basketball game, binary event, only two possible outcomes. Either New York wins, in which case the sportsbook returns Alice's initial stake plus her winnings, and oh, what do you know, there's some profit left over for them. Or New York loses, the sportsbook returns Bob's initial stake and wager, and although there is no profit, there's no loss as well. A key thing here, though, is that this essentially or seemingly riskless operation is only available if you have the proper proportions of wagers in terms of dollar amount on either side of a market. And that is something difficult that sportsbook operators have to do. However, those who operate what is called a betting exchange, the much more popular methodology or modality over in Europe, do not have to. A betting exchange, for anyone with financial services experience, functions identically to a limit order book on a futures exchange, where willing participants are matched in peer-to-peer fashion and serve as counterparties for one another. The exchange simply provides the platform, the technology. They have no counterparty risk. They have no risk insofar as the outcome of any given game is concerned. So suppose, again, our customer Alice, and by the way, for reference, the odds from the previous slide are on the top right. Suppose Alice had a model that said New York had a 33% chance of winning, which would be represented at fair odds of plus 203, which means you wager 100 to win $203. We remember that the sportsbook was only offering plus 190, meaning for that same $100 risked, you would only win 190, and often this disparity is caused by two things. The sportsbook needs to be compensated for providing liquidity and also for exposing itself to information asymmetries, two things that the exchange does not have to, in which case the savings are usually passed on to users in the form of more favorable odds. So what Alice might do is go on the exchange and say, hey, does anyone want to take Detroit minus 203? Because if someone else risks $203 to win 100 on the proposition that New York loses, and Alice has the other side of that, that is the same thing as her wagering $100 at the prospect of winning 203 on the proposition that New York wins. And if you recall, before, Bob only had the opportunity to risk $225 to win 100, so he'd love to accept the opportunity to risk only 203 to win the same amount. Now, of course, they have to make money somehow. The exchanges usually do that by taking the equivalent of a rake or a commission, starting at about 5% of winnings. So what that would look like, again, in our binary event is either New York wins, in which case Bob pays Alice, small percentage of which goes to the exchange, or New York loses, in which case Alice pays Bob, and again, a small percentage goes to the exchange. But if you wanted to look at this, net of fees, after paying any commissions, how would these customers have fared? You can see here how much they each would have won if they correctly predicted the outcome of the game and wagered $100 at the sportsbook. And you can see even after a 5% commission, both of them are better off having used the exchange. Somewhat inversely, if you want to know how much would each of them have had to risk how much of them had to risk to win $100, you can see again at the exchange both parties have to risk less to win the same amount, and ultimately all parties are better off having used the exchange. Regardless of which revenue model you choose, either as an operator or as a customer, clearly the linchpin is the odds at which these various propositions are bet on. And you may wonder where these have come from historically, so let's just step back and make sure to level set and see if everyone is familiar with a particular type of stochastic simulation known as Monte Carlo simulation. I'm sure most are, but just to start from scratch, suppose I had asked you what the probability was of rolling a 1 on a single throw of a 6-sided die. I'm sure everyone in here knows very quickly that to be 1/6 and approximately 16.7%. But for the less mathematically inclined, what you could do is take a 6-sided die, roll it maybe 100,000 times, tally up all the results, convert those to frequencies, and say, given my sample size, I am reasonably confident that the frequency with which each outcome occurred during my simulation is predictive of the outcome with which it will occur going forward. Of course, no one here wants to or even could roll a 6-sided die 100,000 times completely independently, but fortunately your favorite spreadsheet programs and programming languages allow you to do this many, many times very, very quickly. You can see the syntax for Excel and Python in the top right. How does this apply to sports, you might ask? Well, historically, most odds have been created, and certainly if you go on ESPN.com and see the probability with which a win is expected, using something that builds off this exact type of simulation. So here I used real data for the Yankees-Red Sox game that took place in London back in June, and pretty simply I first tallied up the average number of runs that each team had scored until that point, and the average number of runs scored against them. And then applied a very common transformation in this space, which is designed to reflect the fact that for any given quality of a team's offense, the quality of their opponent's defense will affect the likelihood with which you would expect them to achieve any given level of output. We'll of course want to take into account the standard deviation or some form of variability in terms of their offensive output. And then we'll use the inverse of the cumulative normal distribution function and feed it 3 parameters. In our case, a random value between 0 and 1 to start, and then the average adjusted run scored for each team and the standard deviation thereof. And once we have fed a random value between 0 and 1 for the Yankees and the Red Sox, congratulations, we have simulated a matchup. The Yankees won by a score of 10.147 to 7.945, both of which, of course, are rounded. And to make this similar to our dice example and bring this full circle, we don't only do this once, but in this case I did it 10,000 times, iterated through that simulation, so that I could tally up the frequency with which each team won and either convert those into odds if I were an operator, if I were DraftKings, at which people could wager, or as a customer, compare those to prevailing odds and see if I see a relative value opportunity. Now, if you were going to do a real-world version of this, you actually wanted to take or make wagers based on this data, there would be a whole host of other parameters you'd want to include. Home field advantage, injuries, momentum, various dynamics, weather, and the like. And on that note, I wanted to take just a couple of minutes and talk about some of the next generation statistics that are not only being collected, but also fed into some of these models. So computer vision is the sort of class of algorithms that help machines interpret images and videos, and they have been used as broadcasting tools for a while now. You've probably seen some of the different use cases, whether you've realized it or not. Explanatory augmented reality, for example, whereby graphics are overlaid on the field or the court so that fans have an easier time interacting with or understanding a game. Competitor overlays that you're probably most familiar with if you've watched the Olympics and seen, for example, how Michael Phelps is tracking against that yellow line that shows the pace of the world record setter. Viewpoint synthesis, whereby an entirely new vantage point, usually for the purpose of a slow motion replay, is created that was not directly interpreted or at least captured by a camera in real time. And then the newest and definitely most relevant to our discussion is performance analysis, where cameras capture images and interpret them in a way that allows them to measure the position, orientation, and velocity of every player on a field up to and often in excess of 25 times per second. So before I show some pretty cool applications from this last year's MIT Sloan Sports Analytics Conference, I like to put this comic up where I have a supervisor saying to a developer, we want to make an app that allows users to upload photos and tells whether they're in a national park. Developer says, sure, easy GIS lookup, no problem. Says, I also want to check if the photo is with a bird, and the developer says, I need a research team in 5 years. And the point here is that if you're not intimately acquainted with and kind of constantly working in the field of computer vision, it's not always entirely intuitive what the relative difficulty of various tasks are. It doesn't always map onto our more intuitive understanding of what is and is not difficult. Nonetheless, here you'll see a basketball scene that any fans will quickly notice as Michael Jordan playing against the Utah Jazz in the 1998 game finals. And what you can see here that's impressive to me in terms of this computer vision system is not only how accurate it is despite the low 1998 resolution of this broadcast, but also how tight the tracking is maintained even when the players' bodies sort of overlap. As a Jets fan, I hate playing this clip, but this is the famous Odell Beckham Jr. one-handed catch from the 2014 Sunday Night Football game against the Cowboys that took place right across the river. And aside from the freak athleticism on display, what's incredible here is how similar so many of these overlapping pixel groups are. The players have almost the exact same color socks, the exact same color pants. There's blue in the jerseys, the helmets, the spray paint on the grass in the end zone, and still this system does an unbelievable job at maintaining a really accurate mapping of what objects exist and where in the real physical world. And then finally, we have the Germany-Sweden game from the World Cup, Germany kicking a free kick with a man down. And what this showcases, again, aside from some really nice shot placement, is first of all, the ability to recognize multiple bodies on the same screen at the same time, and second of all, to seamlessly transition from one camera angle to another. One of those things that might seem not that difficult, but actually is really not easy at all. In addition to computer vision, we have wearables, which are not only consumer-facing, but at the enterprise level as well. We have tracking chips in the footballs that the NFL uses, in pads, in jerseys. And these have allowed for some really interesting real-time data analysis that is not only real-time, but incredibly granular. Biometric feedback is something that is interesting, if not also controversial. Are you going to be able to bet over under Tom Brady's heartbeat in beats per minute going into the last drive? I don't know. It's an interesting concept people are toying with. But what remains very obvious is that there is an unprecedented level of insight being offered into the nuances of how competitive sports games unfold and how advantages are gained and lost. So we have all this data. What are we doing with it? Well, the idea is that there's been a paradigm shift that is also taking place, a move away from the stochastic simulations and into more machine learning based models. There are a variety of use cases in the sports gaming field, but there are 5 that are really the most common and the most important to know about if you're interested in seeing how this trend is taking place. I'm going to go into each of these much more deeply, but the first would be handicapping, or the process of odds making. The next would be risk management. The third would be bet recommendations. Finally, responsible gaming and fraud detection. And before I go into each of those, I do like to issue some causes for concern. I'm a major advocate of deploying AI across the space. I think there are an enormous number of stakeholders that stand to gain an incredible amount of value, but that doesn't mean it should necessarily be applied haphazardly. And one of my chief concerns is this idea of backdoor functionality, where there are a ton of third-party tech companies developing complicated software solutions that they license out, typically in white label fashion, to sports betting companies that not only lack the technical wherewithal to create the solutions in-house, but to look under the hood and understand what it is that they are buying. And not only does that often lead to a variety of mismatch incentives and expectations, but it gives rise to a situation where those third-party tech companies can install the ability to scrape things like valuable customer or operational data completely unbeknownst to the person operating the software. The black box problem is one that is obviously endemic to the entire AI space and just describes the phenomenon by which incredibly complex algorithms sometimes give rise to unexpected or even undesired results that can't be explained or traced back to their source, especially if you were paying attention to the last talk. IBM is a major advocate of explainable AI for exactly this reason. The flash crash potential is something that anyone in financial services or has followed the markets will be aware of. And again, since making a financial investment and making a sports wager are both about maximizing risk-adjusted return, there is an interesting case to be made that anything you've seen happen in the financial industry, you can see happen in the sports gaming industry as well. And the potential for a sort of algorithmically robo-driven flash crash is one of those potentials. And then odds manipulation and fraud masking are merely symptoms of the fact that just as much as AI can be used by the good guys, it can be used by the bad guys to circumvent those efforts as well. And then finally, on this sort of dreary note, before we get to the more fun stuff, I do like to say that although I see this in a lot of spaces, I see it especially commonly in the sports gaming space, where there's this gold rush. Everyone wants to have an AI-powered system and a machine learning-powered risk management platform. And so what's happening is some tech companies are just advertising solutions that are far less sophisticated than they purport to be, because they don't expect anyone to be calling them out and really, again, looking under the hood and even being able to make that assessment. In terms of handicapping or the process of odds making, I've split this, as the industry generally does, into pre-match, which describe odds on which you make wagers before a game begins, and in-play, which we'll discuss in a second, which describe odds at which you make wagers once a game is already in progress. In terms of the pre-match handicapping, I think that these benefits all need to be viewed not only in the context of increasing accuracy and reducing human error, but potentially over the long term, freeing up more human capital to be deployed elsewhere in the organization. We've seen from the previous section how much data, and an increasingly large amount of data, is available, so it should come as no surprise that having an edge in identifying nonlinear relationships or analyzing large data sets would be majorly advantageous and very preferable to DraftKings, for example, trying to gain an edge against FanDuel. As I play this clip of a neural network teaching itself to recognize MNIST digits, you can imagine that anyone who is in an incredibly data-driven industry would be interested in deploying models that have the ability to improve their own accuracy without an incredible amount of human intervention and oversight. It's simply very appealing, as is this notion of transfer learning, whereby, for example, work that is done to train a model that will be used to predict the outcomes of basketball games can at least seed or lay the foundation for a model that is going to be used to predict the outcomes of baseball games. It's in-play wagering, live wagering, however, where machine learning really adds a tremendous amount of value, and not only in terms of short-term profitability, but also by really vastly improving the user experience and hopefully boosting customer retention. And that is especially important in an industry right now where cost of customer acquisition ranges between $700 to $900, and these costs seem to only be increasing, while the high availability of substitute products corresponding with virtually no switching costs sometimes make it difficult to realize the lifetime value of the customer that you're probably comparing against that cost of customer acquisition. So simply the prospect of putting out accurate real-time odds with confidence. There's a timeout, what are the new odds going to be in the Seahawks game? That is not something that operators have had the luxury of doing. There's been an enormous amount of uncertainty historically, simply because, and segueing into the second use case, historically, most operators have used the most robust possible model to set odds before the game begins, and then a significantly trimmed down model to update those odds in real time, simply because that first robust model is not efficient enough to be run in the small space between downs, between timeouts, between batters, etc. And what this sometimes gives rise to is inconsistencies in odds that can be exploited by arbitrage seekers. And that is really nothing less than a death wish for a sportsbook operator to have arbitrage opportunities being pursued algorithmically by the equivalent of high-frequency traders. For anyone who's not familiar with the space, either from a business or consumer perspective, something that is very common, which would never fly on Wall Street, is the prospect of suspending markets. For any number of reasons, new information comes in, suspicious betting patterns, unbalanced exposures, you can go on to DraftKings, for example, go to place a bet that you're excited to place, especially live and during the middle of the match, and find that they simply have stopped taking wagers on that momentarily, perhaps permanently for the rest of the game. And from a DraftKings, from an operator perspective, not only is every minute spent not taking expected value positive wagers technically financially detrimental, but those are minutes in which your customer might go to one of your many competitors and then never be seen again. So the use of machine learning to really minimize both the frequency and duration of suspensions is, again, not only a thing that drives short-term profitability, but long-term customer retention and growth as well. And then finally, in segueing into the next slide, risk management really is one of the most important functions at a sports betting company. And essentially what they do, if you recall from the slides earlier, they try to get a properly proportional amount of wagers on either side of a market, and they do that by changing the odds to hopefully tug at the supply and demand and kind of get those into the equilibrium that they need. Machine learning offers the ability not only to run much more robust models in real time, but also to predict betting patterns, look at things like user profiles and behavioral patterns, and really have a much more streamlined and real-time and optimized risk management system. And so on that note, being able to balance a book in real time, make sure that the outcome of the game is not going to affect profitability, being able to efficiently implement suspensions, but then also revoke them as quickly as possible, all ladders up to something that increases the turnover being the industry term for total dollars of wagers taken, that a given operator has the capacity to handle. Bet recommendations are something that very soon will function just as the way in which Netflix keeps you watching and Facebook keeps you scrolling. Right now, if we were to log on to an online sportsbook, we would all see the same set of promotions. But of course, as is the case in most of the rest of the e-commerce and tech space, that doesn't really make sense, and it certainly is not the wave of the future. So if you knew, for example, that a particular customer had a preference for a specific type of promotion, maybe they like having their payouts boosted rather than their losses refunded. Maybe you have unbalanced exposure to a team that plays in a geography where you have a lot of current active users on the website, or maybe a particular cohort has an affinity for betting on the number of yards that a given receiver is going to attain rather than a tight end. And whatever these factors are, machine learning is particularly efficient at helping analyze, classify, and create a more curated and customized and hopefully profit maximizing and enjoyable user flow for all of the end users. Responsible gaming is another industry term that it defines the class of tools or mechanisms that help keep customers from falling victim to the ills of gambling addiction. And right now they really exist primarily in the form of self-imposed restrictions or self-exclusions. As a quick aside, I really don't like the term responsible gaming. I think the term sustainable gaming is better because it does a better job of conferring this notion that keeping customers out of addictive behavior and preserving the integrity of underlying sporting events doesn't only affect a few people, but every stakeholder in the sports gaming space and actually every stakeholder in the sports entertainment space more broadly. And again, without going into too much detail here, you can imagine that rather than just having self-imposed restrictions and exclusions, having behavioral profiles where you track how different users who have different betting patterns might interact with your website and the odds over time. How they act on a Saturday at 2 a.m. might be different from their conventional betting patterns at noon on a weekday. Betting only basketball and then one day they start betting baseball are all these indicators that really just show how sort of this pattern recognition on steroids notion of machine learning can be really helpful in operators' ability to proactively assess deviations from responsible gaming and hopefully cut off a problem before it starts. Last but not least, this idea of fraud detection, especially prevalent over in Europe and I think is on some people's radars here in the US, but not to the extent that it will be. The gambling industry has historically always attracted a lot of fraudsters, and the people trying to perpetrate these frauds are growing more sophisticated and technically complex and using a lot more resources in their efforts. And so using machine learning to detect things like betting in syndicates, trying to exploit bonus systems, betting on behalf of third parties, and arbitrage seeking are all going to be necessary simply from a keeping up with sort of the status quo perspective. So to sort of recapitulate, that was handicapping or odds making, risk management, bet recommendations, responsible or hopefully sustainable gaming, and fraud detection. With that, happy to take any questions, and again, if not, I have office hours from 1:15 to 2 o'clock. Thank you very much.
Hey there. Could you talk a bit about maybe some of, from more of like an ethical standpoint, how you think about like the data input to all these models and how different companies have access to different amounts of data? Is that a fair way of doing it? If someone's like TV tape delayed on their stream, like they're 10 seconds behind people who are there live, like how do you deal with that?
Yeah, look, so it's actually a really great question that might speak to even a bigger controversy than you're even aware of, and I'll kind of give the breakdown. So right now there's a massive tension between sports betting operators, DraftKings and FanDuels of the world, and the leagues, NBA, MLB, and the like. The leagues want it to be legally required in every state that in order to offer odds on a sporting event, you have to buy that data, usually at an astonishing price, from the league itself or its officially licensed data distributor. Of course, it's kind of weird. The leagues are almost claiming that the data that their games produce is their intellectual property, which is a bit of a weird claim. You go to Madison Square Garden, you watch a Knicks game, someone makes a basket. It seems weird that someone can own the piece of information that says the time at which that took place, but nonetheless, Illinois and I believe Mississippi or maybe Tennessee, there are 2 states that have legally mandated that you have to buy the data from the leagues or their officially licensed partners. And this is definitely, like, if you're looking at a pitch deck for an investor pitch, a classic risk that people describe is the cost of data going to sort of go up. And there really is a virtual monopoly that exists in the field where if the NBA owns their own data, you by definition can't get it from anyone else. And so that's one thing, is just the cost of data and sort of concentration of resources and things like that. But I think from a different, that's sort of the business and economic ethics. From a personal and privacy ethical standpoint, I mentioned the wearables. It is a very real thing that someone who's betting a lot of money might want to know, what is Tom Brady's blood pressure before the game, and what is his heart rate, and how has that trended over time? And you can see all these pieces of information that would be of genuine and real value to gamblers, but that would perhaps start to maybe cross a line, if that has not been crossed already, in terms of personal privacy. I was at a conference last Wednesday, and this is funny, but someone told me that they bet on women's sports by, first of all, somehow they have some model or something where they think they can predict menstrual cycles, and they bet against women at certain points. Other people who look at NBA players' wives on Twitter, and when it seems there's unrest in the marriage, bet against that player to score a certain number of points. And I can see a lot of the reactions on your faces, like, all right, that's cool, but like kind of creepy. And you're right, it sort of is. And I think this whole notion of what it means to be a celebrity, and once you have taken the extra money that comes with celebrity, what the lack of privacy is that goes alongside that is changing very radically. And so it's a great question, not only from the ethics of who owns the data, and if you want to offer out odds, should someone be able to mandate what type of data goes into that model? It's kind of a unique proposition, but also from a personal privacy standpoint with biometrics and wearables and the ability to collect data on people without them knowing that you're collecting it, it's really interesting. So I don't have a direct answer in terms of what I think the right thing is, but I'll tell you that for sure the ethics surrounding data collection and analysis and use, both from an economic and a personal privacy standpoint, are at the forefront of a lot of the legislative and regulatory debates right now. It's a great question, thank you.
So I had a follow-up because
Sure.
I've actually worked a little bit in that space, and I was very curious. First of all, I think you're absolutely right. It's only a few people own the data, so you can't really look at it. But I was reading something else into something you showed at the end, which is you can potentially get people addicted to behaviors by understanding their patterns of betting and kind of skewing them towards having more opportunities. So you mentioned regulation. Are there regulations to help us do the equivalent of explainability, understand what's happening with the data and the predictions and the things you see? And the second part of the question was also, what rights do the users have?
Sure. So the first question is about regulation, essentially. What, if any, regulations exist that are put in place to either protect businesses and entrepreneurs in terms of the costs at which they acquire data, or the players and the like from what personal data is being revealed? And the answer to that is, as is the case with most fields of regulation, the regulators are struggling to just understand the absolute baseline of what they need right now. There are not many gaming regulators internationally that know what machine learning is, let alone data analytics or virtually any of the terminology that's being discussed here. Something that I do is I do speak out and consult for various regulatory bodies and try to educate them on A, what technologies should they be using, and B, what technologies should they be aware of their adversaries using. The reality is that they right now, there's this states versus federal kind of battle going on, and there's so much that I think it's on their radar conceptually, but not something that they're looking at too tightly, especially since sort of the powers that be, the economic powers, are the leagues and the ones who own the data. And although it is weird for the NBA to say that a basket being scored is a data point that they own, it is the case that if the NBA didn't exist, you would by definition not be able to wager on it. And that's kind of their claim, that if we didn't have a sport, you would not have odds to even be making and taking bets on. In terms of personal privacy, this is a place where entities like the ACLU are starting to clash with the NBA, Sport Radar, William Hills, and the like. And again, I think a blanket answer to almost any question anyone would ask is that we're in the top, maybe bottom of the first inning of this industry. There are 14 states where sports betting is legal and active and expected to head up towards the 48-50 mark by 2025. Everyone is just getting stuff settled. The states don't even have things kind of in coordination with each other. New Jersey has a tax rate of 8.25% for sports bets taken in person and 14.25 or 75 for ones taken online. Pennsylvania has a 51% tax rate. DraftKings is the exclusive provider in New Hampshire because they bid that they would share 51% of their revenue with the state and outbid all the other operators in order to do that. New York has brick and mortar sports betting allowed upstate, but none on mobile. Tennessee has mobile only and none in brick and mortar. So it's tough to apply some of the conventional logic that you would apply to any other industry where you'd say, okay, this seems like an obvious place for a regulator, a compliance officer. The reality is everyone is trying to kind of drink from a fire hose right now and figure out what opportunities to pursue and in what order. It's an incredibly capital-intensive business to be in. DraftKings operates at a maybe 2 to 3% margin at the end of the day. And so it is absolutely needed. I think players are starting to grow concerned about who owns their data, especially things like health.
I'm just guessing there are no open data sets, right, in this space?
So there are no open data sets except the NFL, for example, usually does like a partnership with Kaggle once a year to do a Super Bowl of analytics, and they'll release some sort of open source data.
There was actually an endpoint, the NFL Game Zone or something. There was an endpoint you could drag data from. Yeah.
Right, and now look, there are sites that anyone who has ever scraped sports data will know. ProFootballReference.com, BaseballReference.com, BasketballReference.com. But I would not consider it, right, that's not a league-sanctioned data point. Those are other people. Somewhere in the middle of these are a company like Sports Info Solutions, for example, that has subsidiaries like Baseball Info Solutions. And what Baseball Info Solutions does is, a bit before the advent of computer vision, is they have 40 people whose full-time jobs it is to watch baseball games on a touch screen, and every at-bat say, okay, here's where all of the 9 fielders are, here's where the ball landed. And that creates what looks like, to the end user, an officially sanctioned MLB data set. You know, how else would they get all this information? And in reality, it was just a ton of course, error-prone sort of human effort. So the short answer is no. No open data sets except for those kind of one-off partnerships.